Hello, hello. Can you hear me? Is this working? Cool. Okay. Hey guys, welcome to our ACM meeting. How you guys doing today? Good. Good. Okay. Awesome. Can I ask you guys to do something I'm embarrassed to ask, but can y'all scooch in a little bit here, like kind of into this middle section? So if you're over here, can y'all move in? Like her. Thank you so much. It's weird whenever y'all move in together, we can see so many more of you, and when you're spread out, it looks like there's like no one here. It's kind of crazy. All right, thank you guys. So if you haven't been to an ACM meeting before, just make sure that you're signing in. Also, if you haven't been to an ACM, please sign in as well. So some exciting news. You might have noticed I'm sporting our brand new ACM shirt. Pretty stylish, right? It's nice. Here's the back right here. The ACM shirts are here and ready to go. So if you are a due-paying member, you can pick that up today. If you're not a due-paying member and you'd like to become a member so you can get your shirt, we'll be taking cash, and then also you can sign up online and pay your dues there and get a shirt today as well. So exciting stuff. So some upcoming events that we have. PayCom's coming next week. That's on the 9th from 12 to 1 in Retama. They'll be talking about dependencies and extraction. So if you're interested in any like object-oriented programming or anything like that, please come to that. Dr. Greg White. Who knows Greg White? Anybody? One hand. Ooh, two hands. Okay, cool. So any cyber people in the house? A little bit. Okay, interesting. Well, if you are interested in getting involved with any of that, he's doing a really cool talk that's coming up on the 16th. Right before he comes to do a talk with us, he's actually doing a keynote in Amsterdam, so like it's kind of a big deal. So we're really excited to have him with us. But that's going to be in GSR 2.106. That's the graduate research building. Do you know where that is? Kind of behind the HEB? Yeah? Okay. So yeah, definitely check that out. And I guess that's it. So then, without further ado, we will have HEB come up and talk about Kubernetes. This is Eric Ruiz, who will be kind of like leading us today. One other quick announcement is if you have any good questions or anything like that, make sure that you're asking him. And if you have a really good question, we'll give you one of these Red Packs water bottles. Cool. All right. So, Eric Ruiz.
Y'all can hear me clearly, right? Like it's not a problem. I don't need a mic. Okay. Hey, Matt, I'm gonna kick your laptop off.
That's cool.
All right. Well, okay.
Need it for anything?
No, but it's in this one.
Cool. All right. So welcome. Just kind of quick introduction. My name is Eric Ruiz. I'm a senior DevOps engineer. Is that right, Joe? Okay, I'm a senior DevOps engineer for HEB. Who knows what DevOps is? Okay, a few hands. Who wants to tell me what DevOps is? Go ahead.
It's like testing and like delivery or like deployment, things like
Okay,
that.
you said some good words there. Kyle, what is DevOps?
DevOps is like this setup and stuff like that. You guys stop running and the infrastructure and the program.
Okay, yeah, like if you mix those up, you start to get DevOps. So DevOps, really it's kind of a concatenation of two words, right? Short, but development and operations, right? So typically in the development world, and it's something you as developers or people going to school don't typically deal with, is the operation sides of things, right? So you are writing applications, and I'm assuming most of you are computer science, maybe some engineering it sounded like. Okay, so I might use references in that respect. If you're outside of that scope, I'm sorry, I don't know. So, okay, anyway, so the operation side typically deals with actually deploying the application, right? And developers typically deal with writing code, compiling, and then providing that compiled code to an operations administrator, who then puts it on the server and then makes it available for it to be consumed, right? By whoever that is, either your customer, maybe an internal customer, whatever it may be, right? So cool. DevOps is introduced as kind of this new model or approach to development in which operations members are kind of embedded on the team, and they're very knowledgeable about what the team is trying to accomplish. And so they can actually improve the speed at which developers deliver software, right? Because typically in the past, formal model where the two separate entities, there's just a lot of misconfiguration and miscommunication between those two parties, which really slows down that process. So I don't want to kind of brag too much on that whole thing. If you're really interested in DevOps or understanding it more, Google DevOps, and it's a buzzword, and put it on your resume, because then you get calls, right? Cool, so today we're talking about a technology specific to DevOps, something we use very often at HEB, and most companies are starting to adopt. So, I used a very basic title, Kubernetes, what, why, and how. And I'll kind of go into what we discussed, but real quick, who has heard of Kubernetes? Awesome. Who has used Kubernetes? Okay. Who has written an application? Who has deployed an application? When I say deploy, I don't mean you clicked play in Eclipse or IntelliJ and it said hello world and you're like, I just deployed my application. I don't mean that. I mean, you actually have a domain, right, tied to it on a server, and then you're actually serving up this service to somebody and someone consumed it. Who's done that? Okay, so two. You've done it before. What did you do?
So I deployed, well, several things, but the most recent thing is on Elastic Beanstalk. I made a fast API for order manager for my work.
Okay.
But I've also used like Heroku for Discord bots and DigitalOcean.
So you're familiar with deploying in traditional sense, right? Like servers. Okay. But everybody's kind of understands the concept of a website, right? Like you go to a website, right? Those servers, those files get put onto a server, which then someone navigates to a browser, which the domain points to an IP address, which points to that server, and then as a result, you get the HTML backend that gets served in the client or the browser, right, Chrome or whatnot, and then it displays it, and you're like, oh wow, I'm on Facebook now. I'm gonna update my status, right? So you get that. So Kubernetes kind of takes this this server concept and turns it into what we call containers. I think y'all had a Docker talk last week. Who y'all remember Docker? Who's been working with Docker in the past week? Okay, you have. I know a couple of y'all because I'm Tyler, Kyle, and I know you because I see you all the time, but I don't know your name. Jonathan. Okay, Jonathan, I know your name now. Jonathan, you know those three guys. So aside from y'all, have y'all been working in Docker? No? Have y'all actually tried to deploy an application using Docker? No? Okay. I'm going to have to give a lot of context for this talk then, because Kubernetes can be abstract, but Kubernetes uses containers and basically orchestrates them for us so that we can ensure that our applications are always running in a healthy state. And we can do things like rolling updates and whatnot. So in terms of the Kubernetes, we're going to kind of give you a brief overview of Kubernetes, which I sort of just did. We'll talk about Kubernetes features, kind of give you a high level view. So something we call pods, right? Something we call services. Did they cover volumes last week in Docker?
Yes, well, okay.
They did. Okay. And if you have a question at any point, interrupt me. I don't mind. I like to know questions, and I like you asking me questions. Right, Kyle? Yes. Okay. Cool. So the last thing, Kubernetes config maps and secrets. And what I've learned with working with Kyle on them is that the idea of config maps and secrets and stuff isn't really something you really understand. So who knows what a secret is when it comes to development? Can you tell us?
It's like a key that only the developer knows to be able to access resources.
Okay, what kind of key? Like what could a key possibly be?
It's usually like a hash, like a random string of characters.
Okay, yeah, yeah, but for what purpose?
So a common one is like an API key for a certain service that we're using.
Right, right. Or what about a database? Right?
Yeah.
So when you all write code, I mean, most of you have used databases, right? And you've like connected to a database within your application. So what do you have to provide a database to begin interacting with it? Credentials, a username and a password, right? Yeah, maybe since I'm asking questions, I'll have to look at the answer. Okay, so what do y'all typically do when y'all's code when y'all need to pass a password? What do y'all do? Okay, but you need to provide it to the database, right? You type it in plain text, as I've seen Kyle do plenty of times. Alright, well, let's move past this. A secret is something we want to keep secret, right? We want to keep it safe, it's sensitive data. And so we'll kind of discuss it, but I'm not going to get too deep into how we use it in Kubernetes because, again, if you're not used to abstracting out configurations for applications, it's probably going to be a bit. So let's give the textbook definition of what Kubernetes is. So Kubernetes, and you'll notice K8s. And if someone, I don't want to give away your bottles, but if someone can tell me why there's an 8 there, then maybe they deserve a bottle. Can someone, right, you answered already, I don't want to, okay, now go ahead, what is it?
It's how many letters are in between the K and
Oh
S.
man, you Googled too much. Alright. Yes, that's why. So you're gonna commonly see it referred to as K8 or KS or whatnot, but it just means that there's 8 letters between the K and the S because Kubernetes is hella long to type out, and I don't want to type that out every single time, right? So when you see K8, it's what we're referring to. So here's the textbook definition, straight out of Wikipedia, which I copied and pasted. Kubernetes is an open source container orchestration system for automating application deployments, scaling, and management. That's a lot. Does that make sense to everybody? Everybody knows what it is now, right? 100%. You got it? Cool. You can explain it. Put it on your resume. So we'll take that resume at the end of this. By the way, this is my manager, Joe Rodriguez. So if you want to be nice to somebody, it's probably him. Alright, cool. So you don't have to laugh at my jokes, you laugh at your jokes. Alright. Key Kubernetes features. So I want to try and give you a context around these things, so I'll try and explain it to the best, and if you don't understand it, just be like, dude, I don't know what you're talking about. Explain more. So, service discovery and load balancing. Anybody know what that is? No? I know everything.
So basically, when the load, say you're hosting a web server or an API service, if the traffic is higher, it will scale up and deploy more clusters to serve your cluster. So that's more load balancing.
That's in the realm of load balancing, but typically load balancers won't deal with things like that.
Okay.
But load balancing is the part where it knows of available services and it tries to even out the distribution, right? So let's think Facebook. You think Facebook is running off of one server? Or you think they're running off tons of servers? Tons of servers, right? Alright, so it's likely not one server that Facebook is serving all the traffic and there's one guy's hand. Right? Okay, so it's probably not like that, right? So service discovery and load balancing go hand in hand in the fact that applications are typically going to be scaled horizontally, right? So we have an instance of Facebook, I'll just keep using that as an example, we have an instance of Facebook running that people can hit. But as more traffic comes in, we need multiple instances, more and more instances to be able to handle that traffic, right? But how do we handle the distribution of traffic? Like for example, Jonathan, you come in and you hit server 1, and Kyle then comes in. How does it know that server 1 may be busy and to distribute that traffic somewhere else, right? So that's kind of load balancing. We're distributing the load evenly. That's typically what load balancing is. Now load balancers can get very complicated in configurations, and there's tons of them. But just know that Kubernetes offers that, right? Storage orchestration. This typically comes to how you persist data in Kubernetes and containers. So if you know anything about containers, containers can be started up and they can die, right? They live and die. And so Kubernetes has some way to make sure that certain special things like databases can persist data over time and it doesn't die and the data goes with it. Automatic rollouts and rollbacks. This is probably the most important feature and the most sought after feature when people begin to explore Kubernetes. That is the ability to update my application to version 2 when I update some code, right? But do so in a way that is safe so that my application doesn't go down, right? So let's go back to the instance where Facebook is serving on one server, right? Let's say they chose to do that. And then they write some code and they introduce this new feature and they're like, great, we want to get it down. We want to distribute this out to everybody. What do they have to do to update that server? They got to take it down. And when they take that server down, what happens? Facebook's down, right? And then nobody can, like or change their status to it's complicated or whatever it is. So that's a problem, right? So this is where Kubernetes and containers can help greatly, right? They can automatically roll these updates. They can say, let's start up a new instance of this application, and when it becomes healthy and available, then we'll take the other one down. And then consumers, like yourselves, will never notice that Facebook was ever down, right? And then suddenly it self-healing, so it knows when things become unhealthy and it'll try to recover from those things. Secret and configuration management, I kind of gave you a brief overview of what that is, so it helps us manage secrets in a safe manner, and also pass configurations. And then horizontal scaling, right? So this is the big one. Horizontal scaling is exactly what it is, right? It can increase the number of instances if it sees an influx of traffic to accommodate that. So let's say HEB, right? HEB, did y'all hear about the Selena bag thing with HEB? Did everybody hear that in the news? No? Okay, so we have HEB.com and it runs on a finite set of servers or instances, right? And business said, hey, we're going to sell Selena bags, but I don't think they realized how much people love Selena in Texas or San Antonio and Corpus, more specifically, right? So they didn't really tell the IT side of things that, hey, we're going to sell these things. There's probably going to be a spike, right? A bit of a spike. So what happened was it launched, and then suddenly everybody tried to hit the HEB website to grab themselves a Selena bag. It killed our infrastructure. It literally took it down. Like the site was down. And do you have the numbers on the amount of requests that came in? It was like, they said something like 4 or 5 million hits within a few seconds or something like that when the Selena bags launched. Yeah. And we weren't ready for this. We weren't ready for this, and it came down, and that's the problem with physical hardware, right? We have physical infrastructure where we say we have this finite set of servers that serve traffic. And then you're stuck scrambling to try and serve this request when it exceeds that load, right? So horizontal scaling comes into play. Now Kubernetes is smart. I can tell Kubernetes, I want 3 instances at all times. But hey Kubernetes, if you ever see an influx of traffic and you can't handle it, then I want you to decide how many more we need to scale up and do it automatically. And even better, when that traffic dies down, I want you to scale it back down to what I said. Now why is that? That may not be important to you right now when you're writing applications for your professor, but why would that be important to someone like HEB or Facebook or Google? Why is that important?
Money.
Money. Money. Right now at HEB, we are spending $300,000 a month on running a Kubernetes cluster. A month. But when it comes to running our physical infrastructure, hardware, servers, it's in the millions. Right? And what's the problem with physical hardware? If we invest in 20 servers because we think we need 20 servers and it costs us, I don't know, I'm going to throw an arbitrary number out there, right? It costs us $100,000 per server. But then we find out we don't need 20 servers anymore, we only actually need 10. What happens? We lost out on that money, right? We lost out. We can't get rid of it. We can't go back to Dell and say, hey, you want to buy this server back? We're screwed, right? So this is why the cloud and Kubernetes and whatnot is becoming so prevalent in today's development world, because we can save a lot of money and time. And we get these amazing features. Cool? Everybody kind of on board so far? They're kind of getting it. They're not super. Yeah, you're okay. Anybody have any questions right now before we actually get into? Yeah.
I have a problem as to what would fall under. A question as to what problems would fall under self-healing. Like what issues would appear?
Okay. Yeah, that's a perfect question. So let's say I have 2 instances of my application running, right? And you make a request to one of them, and you maybe pass some bad data or something like that that causes that instance to crash, right? Now maybe you cause that instance to crash, but we still want 2 instances. What happens in that case? Right? Like if we manually had to heal this stuff, what would you do as an administrator? Like when your application crashes on your computer, what do? You restart it, you stop it, and you restart it, right? That takes manual intervention. So what self-healing does is, let's say we have these 2 instances, one crashes for some reason, right? Maybe you send bad data, I don't know, memory, whatever, it crashes. Kubernetes is able to recognize that and say, hey, I see that this person wanted 2 instances, or these people want 2 instances, but one just crashed, and now I only have 1. Let me delete this one, and I'll restart a new one. And I'll make sure that it gets healthy, and then it's back at 2 at what you've requested. Does that make sense? Yeah.
Will it also notify you that that crash happened and how it dealt with it?
Yeah, so that's a major problem in our world, is how do we get tracing to these types of events, right? So the short answer is, it won't notify you. But there is some log output and stuff and ways to get to that information. Now, there are tools that we use to solve the notification piece, right? We're not talking about that today, but there are tools out there that we integrate that allow us to watch for certain things and then notify us if applications go down, or it's scaling up, or it's scaling up. Like all those actions that we're talking about, those events that are occurring. Those are good question. Anything else? All right, cool. All right, so without Kubernetes, again, we kind of talked about the features, so I kind of wanted to give you a picture of like without Kubernetes, and this is very simplistic, okay? So don't judge me on this. But typically we would have some load balancer, right? And y'all use Docker. Did y'all start up containers last week? They had y'all like run a container on y'all's local system? Yeah, no, maybe? Yeah, okay, cool, yeah, all right. And in a traditional sense, if we had some servers that could run containers, which is very possible, we may put some load balancer in front of it, and then that load balancer will distribute traffic across the multiple containers. But then, based on the feature set that I've told you, you can kind of see the problem here, right? Like what happens when one of these go down? Do we get the self-healing that she asked about? We don't get that, right? It's manual intervention. What about configuration management, secret storage? We don't get that, right? Do we get scaling? Probably not, right? You probably have to go in there and you have to manually start up another container. And then you have to go and tell the load balancer, hey, by the way, I started up another container, so now this one's available, right? So without Kubernetes, a lot of this orchestration, this auto magic stuff that's happening doesn't exist. All right. So now I'm going to try and get us into the nitty-gritty. We have to move fast. What time is it? Well, it's 12:21. Okay. So we'll talk about different objects that we work with in Kubernetes, right? So one are these pods, and this is probably the most confusing thing in Kubernetes that people get confused with. So a pod, it's kind of like a one-to-one with a container, except it can contain multiple containers. Yeah. So when you see a pod, you'll typically see an application running inside of it, right? And it may have an additional container running in there, but typically it's one for one, right? So if you run your app and it's in a container, it ends up in a pod in Kubernetes. So a pod is this term specific, this proprietary term we use in Kubernetes. Make sense? Cool. Services. Services are how we communicate with these pods. And we'll talk more in depth about that later. Just take my word for it. It's a Kubernetes object that we have to administrate. And then we have these things called deployments, which are kind of a higher level replica set. A deployment just basically is a definition of the application you want to deploy. The image will be deploying, the ports that get exposed on these containers. It contains all the meta information you need to deploy an application in Kubernetes. I think this is the part where I lose you a little bit, but does anybody have questions here? Any questions at all? Okay. Oh yeah.
I just wanted to know if the pod can have multiple containers, but it usually has more. Like, what would be an example of needing one versus needing multiple containers within a certain pod?
Yeah, that's a great question. So typically, when you see a container or a pod with multiple containers, the primary container is typically your application, right? So let's say we are deploying a UI, I don't know, an Angular application, right, or whatnot. And we're using Nginx to do so, right, serve it up. Or maybe it's just running on its own with whatever CLI you're using in Angular, right? We can typically deploy a sidecar container to do something like route traffic elsewhere or proxy information or whatnot. So let's say we spin up an, are you familiar with Nginx? No. You're not. Okay. Do you know what reverse proxying is? We can do this thing where we can take a look at a URL that someone's hitting, and we can say where are they trying to go, and we use the trading slash, right, like slash API or slash database or something like that, right? And based on that, we can reverse proxy or forward that request elsewhere to get handled, right? So maybe we have a container running serving up a UI, but when requests come in on slash API, we want to send that traffic elsewhere, right? We may have a sidecar container running there watching. And what happens is all traffic comes into the sidecar container, and if it's wanting to hit the UI, it forwards it to the UI. But if it matches a pattern that you told it that it needs to go get handled by something else, it'll reverse proxy that traffic out. That may be an example of why you want a sidecar container, right? Maybe you have some special cache running or Redis database or something like that you wanted there. Maybe that's bad practice. I don't know. But there's a lot of reasons why you can look it up. And if you Google sidecar container, that's the key word there. You'll find probably examples. So take note of it. Cool. Good question though, by the way. Thanks. All right. So we'll get to the Kubernetes pods. I'll give you the textbook definition. Pod unit of Kubernetes application. It's the smallest and simplest unit in the Kubernetes object model that you can create or deploy. By the way, I never use this term Kubernetes object model. I'm only using that today to sound cool. But I usually refer to these things as resources and objects. Okay? Alright, so let's kind of explore a pod. And by the way, if y'all take any courses online on Kubernetes, they're probably going to show that's.
It's here.
Yeah, and you see this model, we're not talking about that today, right? Today, that is infrastructure side, people like DevOps engineers and stuff who worry about managing the cluster and whatnot. I'm showing you all Kubernetes from a development standpoint. So what matters to you as a developer, okay? And that is interacting with these resources, that is deploying your application out, okay? All right, cool. So Kubernetes pods. So I know I just said node doesn't matter in this case, but it sort of does. You can consider a node a VM, a virtual machine. Who knows what a virtual machine is? Yes, all of you know what a virtual machine is. Okay, cool. And at the end of the day, it's a virtual machine which has the Kubernetes runtime running on it, okay? And then it's able to run pods and things like that. So containers, so it's always where a container will run. A container will not end up in a service. A container will not end up in a ingress. A container will not end up in a persistent volume. It won't end up anywhere else but in a pod. Make sense? So it's you organize application parts into pods. So like kind of following up on your question earlier, right? Typically it's one for one because when you run a pod, it's specific to that application. And anything deployed with it, like sidecar containers, are just a helper of some sort, right? But if you have an API, and you have a database, and you have a web server, and you have a caching database, like Redis or something like that, those are all each their own pods, okay? They have the ability to scale horizontally. Does anybody know what scale horizontally means? Yeah? You know? Okay. All right. You want to tell us?
It's just, instead of making like your server more powerful, you add multiple servers of the same capacity to all share the load.
Exactly. Something you're going to hear very often, at least from a development standpoint in the industry, is this concept of scaling vertically and scaling horizontally, right? Scaling vertically is when you say, oh crap, I want to handle all these requests. I'm going to give it a bigger CPU. I'm going to put more memory in it, or I'm going to, like just beef that instance up. Versus scaling horizontally is I'm just going to give it multiple instances to handle. How we've been discussing. Make sense? Okay. And of course, that's better than scaling vertically because once you add a bigger CPU or more memory, you can't get rid of that, right? But if we scale horizontally, you know, get rid of it, right? And we save money, right? All right. Pods are ephemeral. Who knows what ephemeral means? Because I learned when I learned Kubernetes. You know what ephemeral means?
Yeah, it's temporary.
Yeah.
It can come and go as business.
Exactly. Yeah. And so there's I put this in here, this cow versus cattle. Wait. I said that wrong. That was me doing that. Pets versus cattle. It's supposed to be pets versus cattle. Can y'all like omit this? Pets versus cattle over here. All right, pets versus cattle. Joe loves this. He mentions it like every 5 minutes. He loves this analogy. So it's supposed to be pets versus cattle. And so typically what they refer to servers as, or VMs, when you deploy out, is as they refer to as pets, right? Why are they pets? How do you treat your pet? You care about it, right? How often do you have to feed it? Right? You have to make sure you take it for a walk, right? Alright, well if it's a cat, you give it a ball or something, right, yarn, whatever it is. But you take care of it, and it's like this thing you have to nurture, right? And that's a VM, that's an instance, that's the whole operations we need to administrate, we have to take care of it. But cattle, I think I spelled cattle wrong too. No, I think I copied and pasted this, bro. I copied and pasted it, don't worry about it. Man, this guy don't trust Google. Alright, whatever. I'm gonna worry about it. Look, I'm a developer, okay, dude? I didn't get an English degree. Please judge me. Alright, whatever. They live and die, okay? So in Kubernetes world, we don't care whether pods come up or down, right? So that means that a pod may die, and Kubernetes will heal it automatically and bring it back up. And that's the expectation. right? We don't expect it to be available, and if it goes down, who cares? Because Kubernetes will save us, right? So they live and die. And that's the expectation of pods, right? Now that's a problem, and we'll talk about that in a second before I get off this embarrassing slide where I messed up cattle. All right, let's go. Pods, IPs, and ports. And this is probably where, if you're paying attention, you might be able to figure out the problem with the whole ephemeral concept. So, pod containers share the same network namespace. So, that means this IP address is one and the same for this pod and container, right? Pod containers have the same loopback network interface. That just means that anything within the pod, running within the pod, can refer to each other via localhost. Okay, that's all that really means. It's a fancy way of saying that they're all on localhost within the pod, right? So you can't access this container from here and refer to it as localhost. You would need to know the IP address of this this pod. Does that make sense? Okay. Okay, container processes need to bind to different ports within a pod. So that means that if we talk about the instance again that you brought up, the sidecar container, if we have multiple containers running within a pod, because they're on localhost, that means that they need to be running on their own respective port in order to make it accessible. Does that make sense? And am I losing y'all? Is this much? No? Okay, you're okay. Okay, I get it. All right. And then ports can be reused by containers in different pods, right? That just means that like this can run on port 80 and this can run on port 80 because they're not in the same pod, right? Does that make sense? Yeah. All right. So let's do that. Let me kind of bring up a pod here and kind of give you all an example. So we can do something very simple here to run a pod. I'm in a cluster right now. Don't worry how it's configured, where it's at, or whatnot. I'm going to start up a pod in Kubernetes. So, by the way, I have an alias, and I think Matt sent out an email saying to install kubectl and gcloud and all this stuff. You may have done it, you may have not. But if you did, the command to interact with the Kubernetes cluster, the CLI, is called kubectl. Right. Do I need to make this bigger? kubectl, and I have an alias mapped to it, so I only have to type KL. So when I'm typing KL, everything is kubectl, so don't get confused, because a lot of people like Kyle will come to me and be like, why do you type KL, what is that? And I'm just like, really Kyle, I told you this. So, what? Yeah, yep, just blame you. All right, so I'm going to start an Nginx container up because it's very easy. And let me use my cheat sheet here because this is not how I typically deploy pods. There you go, image. Image equals Nginx Alpine, because that's the image I'm going to run. So I hit enter here, and it looks like it was created. So if we go here, actually, let's do this. I want y'all to see it spin up. So let me delete this real quick. Okay. Yeah. All right. So,
We just wanted to
no, that's not why. It's because of this. It healed itself because it started a deployment. There we go. So I started up a pod, and I created this thing called a deployment, right? And I said, hey, I want to start up an instance of this this image in Nginx Alpine. So Kubernetes said, hey, I don't see that one exists. Let me do that for you. So it went into a pending state, started creating a container, and then now it is running, right? And if we want to see that this is actually indeed running, it's just Nginx. So if you ever run Nginx, it has a default page that you can go to. So I'll do this little command here. We'll copy this pod name right here, prove to you. I'm going to forward my local 8000 port to inside the pod and I'll prove to you that it wasn't working beforehand, so I'm not cheating. Darn it. That's because I have something else ready. Alright, let's see here. Alright, well, there it is. It's working, right? What are you doing, test it? Alright, cool. Does that make sense what's happening there? We started up a pod? Alright. So I kind of want to demonstrate because I've asked a few questions about like, what does self-healing mean, or what does like horizontal scaling mean, or whatnot, right? So let's say that we have this pod, this Nginx running. This is our very important app, right? This is Facebook, whatever it is. And we want to suddenly say, hey, Kubernetes, I actually don't want one instance, I want 3 instances at all times, right? So we can actually tell Kubernetes or configure it to always make sure that they're running. And we'll kind of demonstrate this. So if I go to deploy my Nginx, here, don't worry about this, is really like, this is the deep stuff, right? But really right here, this is what a Kubernetes pod configuration looks like, right? This is like all the details that Kubernetes uses in order to determine the state of our application. So let's say I want 3. I'll say, hey, instead of 1 replica, I want 3. And if we do KO get pods, that should walk over here. Suddenly you see that we have 3 spinning up, and you see that 4 seconds ago, 2 more got spun up. Does that make sense? I'll stay watching. We come back to this deployment, we come down here, and change it to Kubernetes spins the other one down. Pretty cool, right? Now there's actually rules that we can add to this whole configuration thing that say like when you see a certain amount of traffic, automatically scale up, right, when you can't handle it, whatnot. I'm obviously explicitly telling it here I want 3 or whatnot, but this is just the general concept of benefits that you can get from it. Does that make sense? Cool. Somebody have questions? No questions? Good? All right. That looks super exciting. All right. I have to get into the presentation with my personal email and we're going to see stuff. What did you say, John? Oh, you said secrets. Yeah, I got secrets. Oh, I found it. It's a Mac thing. Okay, there we go. All right. So, move on. Inter-services. Actually, by the way, does anybody now know, kind of like based on what we just talked about with the whole pods and the IP and things, the problem with every pod getting a unique IP every time it starts up and it being ephemeral and it dies? Does anybody see a problem with that?
You don't know what endpoint to hit.
Right, exactly. If we have 4 servers running, right, we're going back to the server thing, they obviously are going to be assigned some IP address, or you have some load balancer in front of that that everybody hits, and then the load balancer knows about the 4 services, right, and you can direct traffic. But in our case, if we just have pods, and we have 4 or 5 pods running, then, and one of those pods dies, how do we know where to direct traffic at that? Right? If it dies and IP went with it, how do we hit it again? Right? If Kubernetes heals itself, but then assigns a new IP to that new pod, how does it know about it? And I'll give you the answer. It's Kubernetes services. Right? So we're entering another object in the object model that we use to kind of solve that problem. So a service provides a single point of entry for accessing 1 or more pods. Okay? And we're going to try and demo this. But we're going to actually talk about these ones first. So, since pods live and die, can you rely on their IP? Kind of just answer that question. No, you can't, right? So we have an external caller coming in. Let's say you're directing your traffic directly to your single pod. It hits this pod. Maybe that pod tries to go to the back-end pod, but obviously their IP, so that your front end dies. How does that caller know where it did? It does not. So let's kind of talk about the life of a pod. Pods are mortal, so they live only a short period of time, right? You can't rely on that pod IP address for staying the same. Pods can be horizontally scaled, so each pod gets its own blah, blah, blah. A pod gets an IP address after it has been scheduled. There's no way anybody knows what that IP address is going to do it because Kubernetes is doing the work for you behind the scenes. So, nature services. The role of services is that you can abstract this concept of these dynamic IPs getting applied to pods, and you can kind of provide a front with a reliable IP address. So services abstract pod IP addresses from consumers. They're kind of acting as the load balancer, although in a real world production model, you don't really use a service for that, but just know they still have purpose. Relies on labels to associate a service. So you kind of noticed earlier when I showed y'all that crazy deployment. You see how I have this label called run INGINX? So whenever we define a pod, we provide a label with it, like a name or something. So this is kind of what that is right there. I'm kind of trying to signify right there. And you're telling the service, hey, I want you to know about any pods that are running with the label my app. And anytime one comes up with that, you now know about it. And when it goes down, you make sure you no longer know about it, right? And then all our pods, we create them with that label. And then we don't care about what IP addresses get assigned to the pods because our service handles that for us. Our service is kind of doing some service discovery for us. So we kind of mentioned service discovery earlier, and I don't know if y'all really knew what that meant. That's kind of what service discovery means. It means that it knows services are available, and it knows when those services die. So that way, it takes it out of the distribution chain for distributing traffic. Does that make sense? Yeah? Are y'all just saying yes? Yes? Yes. All right. Okay, cool. So, nodes, kubeproxy creates a virtual IP for services. Again, you said you saw that scary graph when you looked at Kubernetes. That's when kubeproxy handles that. So how are these IP addresses getting assigned? How does it know what to assign here? How does it come up with these? How do they die? Where do those IP tables get stored? Things like that. If you're interested in that stuff, then you probably have to dive into that scary chart, right? But know that there's this kubeproxy service behind the scenes that's handling this for us. It's a layer 4, so you're not getting any like TLS termination, things like that, like certs. You know, if you're using HTTPS or whatnot, serving a website. Services are not ephemeral, like we spoke about before. It creates these endpoints which sit between a service and a pod so it knows about them. So I hope this little graph here kind of clears up what that is. So now let's kind of take an approach where that y'all deal with, right? You have a back end and a front end. Are y'all building REST services where y'all have like a back end and a front end, or y'all just use PHP and get it all in one? No? Okay. All right. Well, typically in our world, we build services. So we may have a back end that gives us customer data, and then we have a back end that gives us product data, and then we have a back end that runs and it gives us inventory data, right? And so, in the world of that concept, how it would work is we have the front end, maybe serving up HEB.com, and we put a service in front of it. And so now anybody going to HEB.com is indeed hitting our service layer, which has a static IP, so it never changes, right? And then the pods are living and dying. We have 4 instances, then Selena comes, and so we have 100 instances, and then Selena's gone, and now we have 4 back to 4 instances, right? And all while those IP addresses are constantly living and dying, right? But the service doesn't care because actually no one cares about that fact that the containers or pods are living and dying because our service says, I got you. I know about everything, and I'll get you to someone who is awake and ready to help you, right? Pods in the cluster are able to communicate with each other via services. So in our situation where we have to hit a backend for some data, we have another service that knows about the backend pods running, right? And those pods are able to hit that service because it has a reliable IP address, and thus it sends the traffic off to one of the healthy pods, and the pod goes and gets whatever it needs, customer data, Selena attributes or whatever, and sends them back. and then out comes the request to the front end or the caller. Your question?
So, yeah, you have two different ports on your backend pods. Was that on purpose, and if so, why?
Yeah, it's on purpose because backend here is a generic term I'm using. Now, this may be like above maybe MySQL database running or something. Down below maybe like your Flask app that you have running.
So you have the same service for multiple.
Potentially. And there are certain reasons why you may choose to do that, certain reasons why you may choose to separate it all out and have their own service. So we can have a whole discussion on why you may want to do that because it's architecture, right? At HEB, we do that. I'll get to you right now. We have different models for different teams, right? Typically developers decide what works for them and they say, I want to deploy everything under one big thing and it's all going to go to this because X, it works for us, right? And you have another team that says, well, that doesn't work for us and we're going to do it X, Y, Z, right? And so you have to kind of live in this world of, as a DevOps engineer, how do you satisfy everybody and what's proper and try and help push best practices. Yeah. So why have different port? That's why. I'm kind of just illustrating something. Yeah.
So would you ever have your backend pod go talk to the backend service to get a different backend pod?
Yeah, exactly. So it would be in the case that you kind of talked about, right? Where we don't have a single service hosting a bunch of different types of services, right? We would have, like if this was a MySQL database up top, we'd have a service up top, right? That knows about the MySQL instances, right? We have a service down below that knows about a Flask app or a Python app running, right? And then that Python one might have to hit the service for the MySQL instance. So, make sense? Yeah. So yeah, you can see this endless chain of services hitting services or pods hitting other services, which then hit other services and whatnot. Yeah. But that's for later time. We'll talk about it in the lab if you want.
Yeah.
All right, cool. So here's kind of the world we're living in at this point. All right. I kind of wanted to demo that, and we'll see how this goes. Because we're behind Kubernetes, we're behind HEB's firewall and stuff like that on VPN, so who knows what's going to happen at this point. Actually, I think what I did is I spun up a public cluster so that we could, okay. So I'm going to stop forwarding traffic. We don't have any services running. So what I was doing formerly when I showed you on the Nginx page, what time is it? Okay, 10 minutes, great. When I showed you on the Nginx page, I was forwarding my local host over to inside the pod, so directly, right? But typically, it's not how you're going to serve your application. So what we're going to try and do is we're going to try and use service. And what I'll do here is I will service YAML. Alright, so we have to wait a second. So I'm creating a service of type load balancer. There's a lot of different types of services in Kubernetes. I'm not going to go into that here, we don't have enough time. And you probably won't understand me doing it. So we're going to try and get an external IP that I can hit in my browser that forwards us over to our pods. Right? And I'll kind of try to illustrate. Actually, Steve has a great way to illustrate this, but we'll just use refresh, try and illustrate this. Let's see. Okay, cool. We have an external IP. Okay, cool, it works. Alright, so right now you're probably like, okay, cool, I see the same page, right? But really what's happening here is you can see that I have a service now of type load balancer called my-nginx, and here's the external IP I hit, right? If we come here, and we go and look at the pods that we have running, which are 2 instances right now, and I were to actually look at the IP addresses of these, you see they have no correlation with the IP address that I'm hitting. Come up, you see it has some 10 dot IP address, right, which is like an internal cluster Kubernetes IP address that it knows about. But it does have a label called my-nginx, right? So let's do this. And how we can do this? Let me try to grab this. watching the pods. So we delete this pod, it starts recreating, but all while I'm refreshing, we actually have this one dying, right? And it's trying to start up a new one, but the site never really went down. Why did the site never really go down? Based on what I've talked about today. It's self-healing, but while that one was dying, what was the traffic being directed to?
The one that's not dead.
Right, the one that's not there. Yes, exactly. So basically, if I had a script running here that constantly refreshed this page, and I terminated one of these, and I terminated one of these pods, doesn't matter. It'll just direct traffic to the other one, right? Whereas if I was directing traffic or forwarding, right? If I forwarded that pod earlier, like for example, maybe we actually do that. Let's try that. See if this works. Just do the new one. Make sure I'm not doing the rules. Let's do 80. 80 is dead. Okay, Carol, forward, right here. 80, forward, 80. Okay, so you see, 88 is dead. All right, cool. Forward the pod. Now it's not dead, right? Because I'm forwarding to that pod, right? But let's put ourselves in a situation where we're watching these pods. Refresh. Okay. Open up another terminal. Come over here. Get that same pod. We delete it. And it dies. Make sense? So now we have a service, it's reliable, and we don't have to worry about things like that.
Well, what happened if both pods crash at the same time?
Yeah,
You find
Exactly. Excuse my language. No, that's a real scenario, right? That's a real scenario, like on jokes aside. And that's why typically you don't run 2. Right? You wouldn't run 2. You'd be running 4 or 5. And then that's why alerting, right, is very important that you mentioned. So there's a lot of things that have to go into this ecosystem, right? Because situations like that can occur. And so Kubernetes isn't this silver bullet that solves everybody's problem and your app's never going to go down, but it introduces a lot of elasticity that enables you to attempt to keep your application up as much as possible, to keep it as healthy as possible, right? All right, I think we're kind of out of time. I want to leave a little bit of time for questions. I do want to briefly talk about, just kind of mention persistent volumes. People probably ask, like, how do I store data or store things? If I store, y'all have written applications that write files, right? You may ask, like, well, if I write a file to disk and that pod is ephemeral and it dies, where does that get stored and how do I make sure that it stays available, right? If y'all use Docker has this concept of volumes. Kubernetes has something very similar to persistent volumes, and it's the same concept. It's a storage place that you can guarantee that it'll live and die when you want it to. Anyone with that question? Oh, okay. And then there's Kubernetes config maps and secrets. We kind of talked about that. Here's the easiest way to think of config maps and secrets and what the difference is. A secret is a secret, and a config map is not. So you may have a configuration, right, that you don't want to keep a secret. Like, it doesn't matter if someone sees it, right? For example, maybe you want to say what version of the application you're running, or maybe you just want to provide some meta information that really isn't like a database password. You put it in a config map, right? Database passwords, tokens, API keys, you put them in a secret, and then they get mounted onto the pods when they live, right? And they'll be injected as what we call environment variables. Right? That's actually it for the talk, so I kind of want to open it up to questions, and then I'll provide y'all with some places y'all can go to set up a local Kubernetes cluster and actually play around with these things yourself. Right? And I think Matt has sent out the instructions on what you need to install locally in order to actually work with Kubernetes. So then the additional resources that I provide you right now in a bit is what you need to install in order to actually use this. All right. Questions? Yeah.
So, questions. you know a lot about Kubernetes. What resources would you use to educate yourself about Kubernetes? And the second question is, what would be a good like hello world of Kubernetes, other than just a basic website, I guess?
Okay, so I think answer it in kind of two parts. So the first part, how did I become accustomed to Kubernetes? I was fortunate enough to work for HEB, and they adopted Kubernetes, and they said, hey, deploy something in Kubernetes. Yeah, and then it was kind of a mix of that. But we also have had, there's plenty of places online that have a lot of resources, like Pluralsight, Treehouse. There's a lot of great, when you look at the free content, because those are paid, Medium, you've heard of Medium. They have Linux Academy. They have a ton of documentation around how to set up basic Kubernetes, how to run pods in Kubernetes, how to deploy applications. If any of y'all use any like cloud services, like have you heard of DigitalOcean? DigitalOcean has a ton of resources, and DigitalOcean just announced like a year ago that they were going to introduce Kubernetes as an option as opposed to the droplets. And I think 3 months ago the beta started. I was actually got in, and now you can actually run a Kubernetes cluster in DigitalOcean for very cheap. And so you can play around there. So I think if you just go to DigitalOcean.com, this is paid. DigitalOcean products, they have Kubernetes, so they'll manage everything for you. They can set it up and then you can play with it.
I think the GitHub student pack has some free.
Oh yeah, you're a UTSA student, so you might be able to do something. The other place is GCP or Google Cloud. Go to Google Cloud or GCP. This is where we run Kubernetes, and a little bit in AWS. But you can actually get started for free. And this is what I say, this is the dangerous approach to playing with Kubernetes, because you will have to enter payment information, but it gives you like $300 of free credit. But if you forget to spin those pods down and you leave it running, you're going to be, we're going to get a bill for $300,000. Don't. Just kidding. No, you can do it, just spin it up, and they actually have tutorials that walk you through on how to create pods and things like that. But at the end, it'll tell you, like, remember to delete it, and this is how you delete it, right? So that's another way. And then the last way that I would say that is completely free and really safe is Minikube. So Minikube, you can come to this GitHub, and it kind of talks about how to install it and set it up. But basically, you can host a local Kubernetes cluster on your system, and you can actually deploy applications locally on your system or whatnot. Now, exposing those to somebody, it's not for production, right? It's for playing with it. Cool. All right. Does anybody have any questions for me? Concerns? It doesn't even have to be about Kubernetes. Anything else? No? Yeah. About 3 years ago. No. No. So we introduced it mainly because we are a bit old school when it comes to, as you know, from a development perspective. We operate very slowly, but then Amazon comes in, right? And Amazon, you've heard that Amazon is launching Fresh, and they're doing delivery now. They're doing a lot of this cabinet stuff and whatnot. And the matter of fact is that those companies are very progressive when it comes to a development standpoint. So they're able to develop very quickly, and they're not afraid to put out unfinished products, things like that. Whereas HEB is very scared to put out unfinished products, right? So you can see how that will hurt us, right? They can iterate and build applications very fast, way faster than we can, and they have a lot of money. So people at HEB finally said, or higher ups finally said, you know what, we need to start thinking about and investing in this type of stuff. And so that's where cloud comes in. So it's come a long way since we first began. We were just testing at the beginning, and now we're kind of in the stage of how do we put these actual real applications that our customers consume in the cloud so that we can begin to figure out new products and do it. That's your question? Sorry? Okay. Yeah. Anything else? Oh, we're hiring? No. Yeah, so if y'all want to, sorry Matt, real quick, if you want to check out a little bit more about engineering, or when I say engineering, I mean software engineering, not electrical or anything, sorry. Like your computer? Okay. Well, no, it's bad. We have computer engineers. Check check out our website. It's this new website. It's pretty cool. Digital.heb.com. And they made it like super cool now, so it's super hip to like work at HEB. I don't know, it's a cool website. But it talks a lot about our tech, what we're trying to do, where we're trying to go. We can wear hats now, which is why I'm wearing a hat today. So it's cool. Actually, we didn't know we could wear hats, and like last week they showed us this website, and everybody's like, what the hell, dude, he's wearing a hat, can we wear hats? And then someone's like, all right, I guess. And so like now everybody's wearing hats at HEB. So, yeah, it's like that kind of stuff. But yeah, this is actually the building that I work in. That's not the building I work in down. The one before. That's Austin.
Well, we're getting one like this.
Yeah, so we're actually, they built this super cool like Blue West tech hub in Austin. They have like beer on tap. They have like sleep pods. They have like a library. You know, and then we were like, can we wear hats like in San Antonio? It's like, you know, it's like this mismatch. But they actually announced that we're hiring like 3,000 developers or something crazy. I don't know what it is.
We're hiring about 300 developers.
Oh, okay, 300.
Over the next year. So if you guys are shopping around as you're graduating, please consider us. Like Eric said, HEB is moving towards digital, or the digital space really rapidly. So we're making a lot of changes on the way we traditionally attack problems very different how we do. So it's a really exciting time for us.
Yeah, I'll put it this way. If y'all wanna, if you're looking for, if working at like top companies like Google, like Silicon Valley type stuff is really what you're interested in, you aspire. The closest you're gonna get to that right now in terms of in San Antonio is HEB in my opinion. I have a lot of friends that work at USA, I have a lot of friends that work at Accenture, a lot of friends that work at other places in town, and they're pigeonholed into development positions where they're doing job development, and that's what you need to do. You need to upkeep this application going on. But HEB is trying to compete with Amazon. They're trying to compete with big companies, and we have to take engineering to another level in order to do so. So we are using the latest technologies, the latest tech stacks. We're continuously being progressive. We have beer on tap now in Austin. But we're actually getting one of those buildings here in the next couple of years. So we will have cool stuff like that too. So if you want to work for a really good company right now, I think HEB is probably the best and closest you can get to that outside of Silicon Valley. Thank you.
You guys, so head up this way. Again, if you need to pick up a shirt, you can do that. Go through the line. If you need to pay, like if you want to be a member and you want to get a shirt to pay, come see me. I'll be sitting right over there.